Thank you. Thank you so much for the introduction. Uh, First of all, I really want to appreciate this opportunity to speak. I'm sure many of you in the audience might already know me, and I would like to share my screen. So just give me a moment. Okay, are you able to see my screen?
Yes, sir.
Okay, perfect. Thank you. All right. Hello, everyone. Myself, Hemang, and I work as a product leader. My entire uh, experience is into e-commerce and fintech, on e-commerce business, consumer side to B2B commerce. And today I would like to discuss about, AI analytics and especially how all the AI projects basically going from pilot to production and how what are the challenges that every organization that face. So a very interesting fact that I would like to start with. Many of people, even in the audience today, right, you might have seen your company has built an AI agent and demo in the last year or a few. Only if that agent is running in production today, right? How many have you seen that's being real and the real customer and real system of record is being utilized, right? And that gap between just the pilot project for being having that agent run in your local environment or in your production environment, right? And that's the entire talk I would like to have today. And that's the distinct between a demo that gets really, nice feeling in the room and the system that actually business trust. So I build AI projects in the environment that I live in, and for next 20 minutes, I would go through the blueprint that I believe would be a successful framework for enterprise ready products. So let's look at uh, this one first. So here is the surprising picture that you can see. At the top of the funnel, every AI pilot that we proudly kick off that you see, and at the bottom, that is where the thin little thread, the one that actually made it into the enterprise production, right? So there are the two numbers that tell the real story. Like 95% that you see of the enterprise generative AI pilots are the production zero measurable return, right? And that's the actual MIT research which and the Gartner forecast research that says 40% of agentic AI projects will be either canceled or dead by 2027. So that's also a scare in the world that we live in where everyone moves to the AI transformation. Now I know by looking at this, many of the people are thinking in the audience that sure, I mean that can fail just because the companies has built it bad way, right? They might not have taken care of few things that is very important. But let me give you a very good example that's published by Klarna on their official website. Their AI assistant did the work of like 700 full-time agents, and it was like poster child where everyone's favorite slide. And then by 2025 they started rehiring human agents again, or human itself, right? Because the quality and the trust gap that showed up in the production that never showed up in the demo that they have run with their team. So the lesson here isn't like AI doesn't work. It's that a demo and the production, there are two different worlds that they live in, right? A demo has to work once uh, for your friendly audience with minimal data, right? You are working in a very controlled environment, but production has to work like 10,000 times more bigger environment. Yeah, there are strangers coming on your system and the website on your worst day. So how do that perform, right? So that's what's the most important part. And here is the core insight I want to carry through the every slide, which is like the trust, right? Not the model quality. Like is that is the constraint that decides who ship. The team that wins the next 2 years are the one like with smartest model. They are not the one whose agents the business is willing to trust with the key, right? So that's where I want to begin further. So let's look at the semantic collision here. What does that mean and where integrations catch the fire? So why does the production break, right? Really, that's the question comes to every team when they go into the production. And let me show you the collision at the heart of it here. So on your left, that you see your agent, which is a rule-free, and adaptive. It reasons it fuzzy human intent, which is exactly why it's magical. And on the right side, what you see is your enterprise SAP system or Salesforce or whatnot, right? That has the fixed schema, strict rate limit, like under yield rules. So system that do exactly what you tell them to every time forever, right? That's how it works. And when you bolt a probabilistic thing directly onto a deterministic thing, then you get a collision, which is the 70% of developer reports that critical failure integrating AI agents with their existing system. So we have seen, like, if we are building a new product with AI, that's really working a little bit better than while you work with your legacy or, existing ecosystem. And that shows up the three flavors here. One is the semantic drift that you see, the model hallucinate field mapping because it confuses client with the account, for an example, as a field, which is subtle and quietly wrong. The second one is unbounded access. The agent gets you into a reasoning loop and hammers an API until it trips the rate limit, right? And that takes the integration completely down. The third one is unsafe execution. So one wrong autonomous action that writes directly to your live database, and there is no going back. There is no fixes. That's like, a midnight phone call your developer team don't want. And notice none of these are the model is really not well or dumb, right? The model is really brilliant. There are many models out there which is really brilliant and performing well. But the problem here is we let the brilliant model and improving things reach straight into the system that have no tolerance to improvisation. And that's where I have this architecture framework that you see, which is, so here is the reframe that changes everything, right? Most of the teams that spend their energy trying to build a smarter agent, but I want to convince you to stop that. Like, the agent is not the product, right? The control system around that, what you build, is your real product, and then you can ship it safely. So look at the diagram here where there is a agent in the core, where you see in the orange color, that's the real chaos or the creativity that sits in the middle, but it never touches the entire enterprise directly. Around that, there are, control plan that you need, deterministic membrane, or every read, every write, every decision that passes through. So that's the mental shift, right? Stop trying to build a smarter model. Build a deterministic membrane instead that lets unpredictable component operate safely inside your predictable systems. And as a product leader, what I see is, like, this is freeing up many team members from their repetitive task, because you stop betting your roadmap on the model getting better, which you don't control in reality, and you start investing in the system around it, right, which you completely control. So let's look at the five pillar control system here that I want to walk you through. So what is that membrane made of, right? These are the five pillars that's very important. This is the spine of the whole blueprint, and the rest of the talk is what I want to spend on each of the pillar, right? Messy AI intent comes in the onto the left that you see, like clean, safe enterprise executions come out on your right that you see, and in between, these are the five gates. The first one is the contract, which is like separating reasoning from execution, and I will deep dive a little bit deeper into it as we move further. Constraint, which is to bound blast radius, and I will go into the details what that means. Evaluate, which is grade the trajectory, not just the output, right? Then observe, trace the complete decision path, and recover, like engineering safe and graceful failure, but then you ship your product confidently. So contract, constraint, evaluate, observe, and recover. This is like, a five pillar of the overall framework that I would like you to remember from today. And let's walk through, each of them in detail. So let's look at the first one, the contract, right? That's the integration standard. What that mean is, the rule here is just one sentence. It's non-negotiable, right? Never let your AI agent touch a system of record directly. Watch the complete flow. The agent says, like in a maybe a fuzzy human language that says update the client address, and that's great, right? But that's kind of a useless to a system like SAP. So that intent that passes through a translator that should built on the model context protocol (MCP) and a unified APIs like tools like Truto or Nextla, and that comes out the other side as a strict, which is like a typed JSON format contract that you see, which is a schema version, and that's the real action, right? That's the target entity and validated payload that you should trust on. Now, here is the division of labor, and it's the whole game, right? The probabilistic agent proposes, but the deterministic serves the validates and executes. So the agent is allowed to be creative. It is never allowed to be, the final authority. So for product leaders like me or the others in the room, think of it as the contract between chaos and order, right? The agent that brings the idea, but the contract decides what actually allowed to be done or allowed to happen by that agent. Now the pillar two, which is constraint, which is bounding the blast radius. So a contract tells the agent how to ask, and the constraint decides how much it's allowed to do before a human steps in. Right? We call it a autonomy budget. So if you look at this, the image here, and at the center there is an agent which is, let's say, a read-only agent that can look at anything all day very safely. And then in the middle that you see is a reversible agent which writes the action. Those it can do autonomously, because then if it's wrong we can actually undo it or fix it. And then there is a outer ring which is completely irreversible actions, like for example, if you want to have refund, you have deletion, you have anything that you can't take back. So those always requires human the loop, so you can have the make the right judgment. Then you treat the agent like what it actually is, right? A non-human identity with least privilege scoping, and you cap it. You can actually define it per task. You can have the token limits. You have a tool call frequency, and your each dollar spent basically go wisely. So remember that runway loop I mentioned in earlier stage, the agent that gets stuck repeated itself and hammering the system, right? Then once you have set this cap, there is no longer a crisis, right? The agent hits the limit you set, it stops when it's supposed to, there is no surprise bill, there is no system going down, and you have decided ahead of time exactly how much can go wrong, right? And you are living in a controlled environment, because I have seen companies actually spend millions of dollars on tokens, and they don't know where that goes, and your system is not efficient enough in a way when you spend too much investment. So let's look at the third pillar, which is evaluate. Grade the journey, right? Not the answer. What that means is this is where the most teams like testing quietly lets them down, because a correct final answer can hide a reckless path. So the old way that we have seen, like what is your output testing looks like, only checks the point A to point B, right? Did the agent give the right answer? Great, then ship it. But that misses the scary part here. It doesn't catch when the right answer was reached by calling, let's say, a wrong tool, or by touching the data the agent had business idea on. So it's like grading a road trip, only whether the person arrives or not, right? So they can make it to the place that they want to reach, but you didn't see that how they drive through and they cross the three red lights, and somebody just loan them to get there. So you see the final result, but how do they basically reach there is also a very important factor. And similarly in agent world, you should do the same thing. So we grade the journey here, right? Trajectory evaluation that scores the entire execution path, your prompt, your retrieval tool calls, your self correction, and then the final answer. There are two models to it. One is the LLM as your judge for offline evals that gate your CI/CD releases, and then there is online evals that watch like real-time production traffic for semantic drift, right? So you are not asking was it right, you are asking was it right for the right reason and the right way, and that's where you have to evaluate your system. Then the fourth pillar is observe, like tracing the question why, right? So evaluation tells you something went wrong, but observability will tell you why it went wrong. And this requires a real shift in what we monitor. So traditional application monitoring like APM that watches the latency and uptime, did the service respond or was it fast, necessary? But for an agent, now nowhere near enough, right? Because APM catches 500 error. It does not catch an agent that confidently did the wrong thing in, let's say, 200 milliseconds with a perfect green signal. That's not really an error, but you have to observe your agent is not performing well enough with the right systems. So even though their answers is right, that might be just for intermittent and not throughout the scenarios, right? So we shift to AI observability where quality and reasoning happens. The standard is to adopt open telemetry's Gen AI semantic conversation and capture the full nested trace, right? It's session, trace, or prompt, retrieval, tool calls, or response. And the platform like Maxim AI, right, Langsmith and Opaque, if you might have heard all of this, are built to catch quality degradation and infinite reasoning loop and safety regression. So the one line that I would like you to hold to is if you can't replay the multi-step decision path, then you can't debug the agent, right? And anything you can debug, you can't put in front of a customer. So now let's look at the fifth pillar to recover, right? And that's right, very important for engineering. That's the engineering safe failure, I would say. So, and this is the one mindset before it's a mechanism, right? The whole pillar starts from the honest assumption that is the agent will fail, designed for graceful recovery anyway, right? And that should be the philosophy. So, we borrow from the pattern distributed systems have used for years, and circuit breaker when upstream system errors or say pricing goes down or the agent doesn't keep flying and it trips the breaker, right? So halts gracefully and hands off to the human in the loop dashboard. That's what you should build for. There are three tools in the kit here, which the one that you see, the the key. So there is a retry that doesn't accidentally charge the customer twice, right? And that should be established. Then the state checkpoint, so you can pause and resume a long workflow instead of starting all over again. And then a kill switch, which is a global disable execution flag, or disable execution, which flag for when an agent goes badly off the rails, right? So the production ready doesn't mean it never fails. It means the damage is bounded, visible, and reversible. That's the bar that you have to set, not the perfection. That's called recoverability. Now let's look at the integration architecture diagnostics here. Now, very practically, how do I connect to my ERP and CRM without recreating the collision from slide that we have seen before, right? That's the question everybody should be asking. And these are the three architecture choices. They are not equal. So you are basically got three ways to connect your agent to your ecosystem. The first one is the native option using the AI that's already built into a platform like SOPGL, for an example. So it's safe and well governed because that is a vendor controlled environment. The catch is you are locked into the vendor and it does not travel well to your other system. The second one is to bolt your agent straight onto a public APIs, right, which is flexible, so you can connect to almost anything, but you are exposed to a rate limit. So one busy afternoon, like your agent makes too many calls, for an example, the system throttles you, and then the things start breaking. Then the pattern I would steer most of you toward is the unified API and the data abstraction layer, which is true to our Snowflake. That family, isolate that is the family which isolates reads and write and near zero rate limit exposure and high cross platform flexibility. Right, it's the deterministic membrane where made real and sitting between your agent and your system of record. So let's look at that operating model, right? So either you are a decision maker in the room, or you are a product leader like myself, or you are an engineering manager, So I would go through each of them, what they should be looking at. Like if you are a decision maker, you should fund the system, not just the demo that is being presented. Look for the budget for the controlled environment and the evaluation and the observability, not only the model inference, right? And track the trust and the unit economics, not the novelty. If you're a product leader, then you should sequence for trust, right? Pick the reversible, high volume use cases first, win the credibility first, and then expand on it. And define the human escalation and override the experience deliberately. That's the handoff is that handoff is the product design, right? Not like just looking at the edge cases. And if you are an engineering manager, then you own the boundary, like build the anti-corruption layer as your first class mission critical code, not just a glue script that you should traditionally work on. And then standardize on MCP and open telemetry so you stay portable at any point of time, and it's a flexible architecture and environment that you can build upon. So, if we look at the future, and if I have to, put it in a 90-day roadmap or a path to go to a safe production uh, path, then how does that look like, right? So this is the part, and the timeline can differ, but this is just for the easier to understand. I would say 90-day path to deploy in the production. And if you want to, let's say, start maybe a next week or a month, here is the 90 days version that you should look at with the framework. So if you see the day 0 to day 30 for the first month, what's the most important thing that should be established is the contract and constraint framework, which is wrap one system of record behind an MCP or your unified APIs, and then add allow list, and then pick one strictly reversible use case. That is very important. Then if you see, if for the maybe a second milestone would be evaluate and observe. So stand up for trajectory evaluation in your CI/CD pipeline that we went through. Then attach an observability sidecar there where you establish your baseline for trust and API cost. And then the last milestone would be recover and release. So you implement the circuit breaker and keys to controlled environment, then ship to a limited production behind a kill switch with the human escalation path. So it is way controlled, and then define a one use case, and then you can move safely. So that's a nice way you can build enterprise ready AI agents, right? So I would now leave you all with this, five words or idea that should live with you after this demo, which is contract, constrain, evaluate, observe, and recover. So the teams who are stuck in the pilot projects or a demo that is being presented to your leadership team, which looks really promising, but the moment that you go live or scale it at the enterprise level, then it's things started breaking, and the revenue that you have assumed to get back is not happening anymore, and your leadership is no more happy. So that's why I would like you to take this back, and the teams that ship treat the agent as one component inside a system that they actually control. So the agent is not the real product, the system around it is your real product. So build that system, and your pilot really stops being a demo, and that becomes the enterprise infrastructure ready. And the percentage that we have seen in the research would go fail will be definitely decreased. So I would like to end this session with just one question that you should all be asking yourself and your team. Which is the part which is the hardest in your organization today? Is it a contract framework that we have seen? It is a autonomy boundaries? Is it a eval? Is it a observability or a recoverability? So, ask yourself where you want to put your more energy towards to make your enterprise ready application. Having said that, myself, Hemang Upadhyay, and if you would like to have any type of discussion around that, where we build the product that shape the market with the AI, I would happy to connect with you guys on LinkedIn. And you can also look at my website and reach out to me. So thank you so much for this opportunity today. And thank you to all the organizers as well.
Thank you, Mr. Upadhyay, for sharing your expertise on leveraging AI and analytics.